Alrighty, everybody, welcome to the first lesson here in our statistics unit. So we'll get into, mean, median mode, methods of dispersion, central tendencies around a mean, normal distribution, and usually like all of those words are very overwhelming when you hear them all at once. But essentially what we'll talk about is that bell curve distribution, which you hear a lot about. Post-secondary in terms of grading and marks and averages and things like that. So we'll talk about what all those things mean, and all the things that it will help us do, and it really helps us analyze trends in society is where you see this most often. Okay, so we'll start very basic in terms of describing data and some of the words we can use to do this. And many of these people do on a daily basis anyways. It's just a matter of putting that context into our language. So there's two different types of batteries that we're going to look at, two different brands, and you have the lifespans of 12 of them. You've got brand A, brand B, and in years you have those numbers to the nearest 10th. And if you're looking at which one you would choose, we need to come up with a reason as to why. And one of the most common things that people to do is, I want my battery, especially for my car, to last as long as possible. They're not cheap. They run to you anywhere from $100 to $300 for a car battery. So you want to make sure that money lasts and goes a long time. So if you look at all of those numbers, those years, one thing that people could do here is find out, the average of them. Which one on average would last longer? It's hard to know the life of an individual battery, but if given a large number of them, we can be reasonably sure that we're picking a battery that will last the longest. So if I look at all the batteries from brand A, of which there are 12, if I take each of those numbers and add them up, the way that I can calculate an average or a mean is by taking out all of the numbers that are present and, adding them all up, and then dividing that number, I get that sum, by the total number of items that I've added. So each of these numbers again represents one battery. So really I'm taking the average to, find out the average lifespan, because I can't be reasonably sure that when I choose a battery it'll last for 3 years, or it'll last for 6, or it'll last for 10. I don't know. I have no clue. So this gives me a nice way to make a general statement here. So I've added up 12 of them. So there's the first sum. So brand A's average is about, we'll do 5.6 years. And if I do the same thing for B, so I've done this ahead of time, for brand B, its average lifespan is 5.7 years. Now it's not, it's not a big difference, but you would pick the one that lasts longer. And again, the caveat here is it lasts longer on average. You might still pick a battery from brand B and it dies after a year. That's still possible. We're not saying that it will always be brand B, but you can reasonably be assured that brand B would last longer by comparing them based on their average lifespan. Okay, so statistics helps us to do a lot of things, and it really is just the study of collecting, analyzing, and interpreting some data. Okay, and there's a lot of different ways we can do that. Central tendency is one of them, right? So we describe all the central values of that data. So the mean, right? The average, what is everything centered around? The median, that middle value in a set of data, or the mode, the one that's the most repeated. Right? And these are three words that generally people have heard before. Methods of dispersion, however, is a little bit different. So really we're going to talk about how spread out the data is. So comparing the smallest value to the biggest. Right? What's the range of this data set? Standard deviation, how far away from the middle are each of our data points? Right? How far away is one from the middle? And measures of shape. So a histogram, right, could show the frequency. So imagine you pick 12 of those batteries off a shelf, and the lifespans of each of them happens to be 10 years. Well, you get really lucky. And frequency just talks about how repeated a value is. Right? And that normal distribution is where we'll work up to, and really it shows us that bell curve shape. Right, the symmetric distribution of data around the middle. Okay, so that's where we're going with this. So let's give this iPad just a sec. There we go. It'll kick in here. There we are. Now, just given some data sets, we can go calculate a couple values here quite easily. So we'll look at these two different data sets. So we're asked to determine the mean, the median, the mode, and the range to do this. So every time we're going to look at a data set, it's helpful to rearrange the values in terms of, well, smallest to greatest. Right? It's going to help us find the range of that data set, how far the numbers span, also with finding the middle in that data set. And it's a problem because, well, there's a lot of numbers. So usually when I write one out, I'm just going to cross it off the list to make sure that I've taken care of it, and I don't count something twice. So I got 5, 7, 9. The next ones are my 11s, of which I have 2 of them. 14, 16, and 17. So I've reordered them, and I need the 18 on the end. This is why we crossed them out. So there we go. I've got the same data, just reorganized from smallest to greatest. And now I can actually look for those 4 measures that we're asked to look for. So the mean. In other words, the average. So if I add up all those numbers and divide by how many numbers I've added, this will get me what I want. So 5 plus 7, 9, 11 twice, 14, 16, 17, and 18. Okay, so we get a sum of 108, and that's 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. So we'll divide that by 9, and it looks like the mean here is 12. Okay, so sum, I'll write that out here, sum of all data divided by the number of data entries. Okay, so I got 12. The median. And the median in any data set really is just the middle value. So I like to do this by, taking and crossing out the smallest with the biggest at the same time. And as you work your way in, you'll start to see the number in the middle. So 5 and 18, I can cross out, 7 and 17, 9 and 16, 11 and 14, and I'm left with a perfect value in the middle of 11. Right? 4 numbers on either side of it. So my median here is going to be 11. The middle of the data. Okay, so the middle of the set of data. The mode comes next, so mean, median, mode. And all the mode is the most repeated value. And if I look at this data set, I have 11 twice. It's the only number, so 11. Most repeated data entry. Right, the most repeated value. And then the last one is the range. Okay, so the range, how far do the numbers span? And I can take the largest number and subtract the smallest, and it will tell me how many numbers this set spans. So if I do 18 minus 5, I get 13. Okay, so that'll be the range of numbers. It spans 13 different values. Okay, all the way from 5 to 18, there's 13 numbers in between. So there's my 4 common numbers we'll talk about with central tendency, mean, median, mode, and the range is helpful as well. Now, if I try this out for B, we can do this the same way, but there's a little bit more numbers here. So we'll do it the same. So 2 is the smallest, then it looks like the 9s. So there's 2 9s, and next would be 11, and then 12. There's 2 13s, 15, 17, and 25. So 15, 17, 25. Okay, got them all reorganized. So let's go find out those values once more. So a mean. And I can go add them all up. Right? I can absolutely do that. And if I add them all up, now let's plug them in because I didn't do this one ahead of time. So 2, 9, 9, 11, 12, 2 13s, 15, a 17, and a 25. So I get 126, and we'll divide that by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers this time. So this time I get a decimal, which is okay. 12.6. Right, that's the average of that set of numbers. The mean. The median. Okay, median, I'm going to go look for the middle. So we'll take the look at the smallest and the biggest, and then work our way in until we get to the middle. But this time what you'll notice is I have two numbers that remain this time. Right, I can't really cross them both out because I got nothing left. So I have four numbers on either side still again. So if I ever come into this situation where I have an even number of numbers, the median is the average of the middle two. Okay, so average of the middle two values. So this time I would have to do 12 plus 13, divide it by 2, because, well, I'm taking the average of two numbers. So 25 divided by 2 to get me 12.5. Okay, so there's my median. My mode this time, well, again I run into a little bit of an issue because I have two repeated values, right? I've got 9s that show up twice, 13s show up twice as well, and I can't really decide if it's one or the other, so I have to take both, right? 9 and 13, right? How do I know it's 9? How do I know it's 13? They both repeat an equal number of times, so I have to take both as part of that mode. The range hasn't changed, so biggest value, smallest, subtract them. So oops, let me make that look a little nicer. 25 minus 2, my range here spans 23 values. Okay, so same thing. The only real change is, well, to do that median, since I've got two numbers in the middle, it's the average of those two middle numbers. Now all of this we can do with our calculators as well, but you know, just showing you how it can be done by hand. We'll talk about the calculator piece in just a minute here. But let's go see how I can use this idea about an average or a mean to determine something that's missing. So I know this time that the mean of this data set is, well, 7. You're looking for one of the missing possible values. So if I think about how we did this, the average was the sum of all the numbers divided by how many numbers I have. So if I take all of these values and add them up, right, 10 plus 4 plus 7 plus 12 plus 9 plus 4 plus 6 and plus x, if I divide that by however many values that is, so it works out to be 8, right? There are 8 things we're adding together, the 10, the 4, the 7, the 12, the 9, the 4, the 6, and the x. That's 8 things. So divide by 8, I'm going to need to have 7, right? I'm told what the average is this time. So now it's a little bit of a case where we need to work backwards to find out what's missing. Now, there's a lot of things to add together, so let's simplify it just a little bit here. And, you know, if I make this look a bit nicer, well, if I add up everything on the left side, it works out to be 52. So 52 plus x divided by 8 is equal to 7. And I can solve this relatively simply by multiplying both sides by 8. So I'll be left in a place that says 52 plus x is equal to 56. So in order to make that happen, the only number x can be is 4. Okay, so just by using the same idea, work backwards slightly, you know, I could determine a missing value as long as I know what the average is supposed to be. Right, I have to have at least that to find out whatever's missing to make that average happen. Okay, so with the last one, I did mention that you can do this using our calculator as well. So let's see how we can do that. And the calculator I'm using is a TI-84. The 83s will work as well. The buttons might be slightly in a different place, but they do the same thing. So you've got a table here, amount of rainfall in Banff, right, every month over a given year. We don't know what year that is, but it doesn't matter. Determine the mean, the median, the mode, and the range for this amount of rainfall, round to the nearest tenth if needed. So I can do all of this by hand, of course, but let's try to use our calculator. Maybe we can do this a little bit faster. So one of the buttons you can press there is the stat button. I'll hover my mouse over it a little bit. It says stat right on it, so click it. Edit is option 1 that comes up, and you're going to see a bunch of tables here, and this is where we're going to put all of our numbers, all of our information. Now, it doesn't matter what order you put them in. You don't have to rearrange it from smallest to biggest, nothing like that. Just put in all the numbers. So I'm going to go from January to December. I'll go in order. So 28 is the first one, and once you have it in there, you can just press enter, and it will get you down to the second line. So we'll put in all the numbers. So 22, 23, 32, 60, 82, 54, 60, 42, 29, 27, and 16. Okay, so I've got all of my numbers in there. I'm pretty sure I didn't miss one, but there is a way to double check in a second. So once all the numbers are in there, press that stat button again that we pressed to get here. And then we're going to press the right arrow to go over to calculate. And option number 1 says one variable statistics. Okay, that's what we're going to calculate. I only have one variable here, it's just the rainfall. So one variable stats. Now since I've defined everything in that list number 1, I don't have to tell my calculator which list to do this. By default, it will use list 1. If you need to actually tell your calculator what list it is, above your number keys, right, 1, 2, 3, 4, 5, 6, in blue you can see list 1, list 2, list 3, list 4, list 5, so I can even tell my calculator, run those statistics on list 1. It's a little bit redundant here since it'll do it by default, but I can click it anyways. And here is a bunch of numbers with a bunch of symbols that my calculator is going to tell me. So it just did all of the things I needed to. We just need to be able to know which symbol means what. So for the mean, the symbol is the X with the bar on it. Okay, my calculator has the X bar at the very, very top. That stands for the mean. So to the nearest tenth, it is 39.6. Right, so if I were to add up all the months of rainfall and divide it by 12, I would get this as an average. And I know I put in all the correct information. I didn't miss a value because on that calculator screen at the very bottom, it says n is equal to 12. N is the number of pieces of data you've entered. I've entered 12. There are 12 months in a year. I didn't miss one. Okay, so I know I have the right amount of information. Next is going to be the median. Okay, so on our calculator, what I'm going to look for is, there's an arrow at the bottom here where the n is. That means you can scroll down and there's more information. And I can see the word MED. That stands for median. Okay, so on my calculator, my median is 30.5. Just like I would calculate if I was going to do it by hand anyways. And I had an even number of months, so I'm going to get to a place where the middle 2 months I'd have to take the average of, leaving me with the decimal. Okay, so that makes sense. The range. I can use my calculator to help here with the range. Now, it doesn't tell you the range directly, but what it does tell you is the maximum value of X that you've put in, the maximum data value, and the minimum. So I know the maximum is 82, and I know the minimum is 16, and we said to calculate a range, you subtract those two numbers. So I don't really have to look through the data set to find them and reorder this. My calculator will do that sorting for me. So 82 minus 16 for a range of 66. And the last thing you're asked to find is the mode. Now, unfortunately, your calculator will not tell you a mode, so you really have to look through the data set there in order to find it. So the one value that repeats, 60. Right? And it is the only one, I believe, that happens more than once. So my mode is 60. Okay, so calculator is super, super helpful to determine that. Don't have to do any of the sorting, really any of the work. It will take care of it for me. Okay. A little bit about standard deviation here too, and what that kind of means in a visual sense. So it's a measure by which we describe how spread out some data happens to be. And there's a symbol for it as well. Sigma is that symbol, a lowercase, again, a Greek letter. And my calculator will tell me this as well. If I go right up to the top, there it is. It looks like a little O with a weird little tail or hat up at the top. That is my standard deviation. So basically, what it tells you is that this is how far your data is spread out from the average. Now, if I have a high standard of deviation, it means the data is really, really, really spread out. So if I knew what the average was, for example, let's say we have an average of 3. Actually, let me use the symbols there. So let's say our average is 3, and our standard deviation is 5. So if I knew what the average was, I could list out the next value in this data set because the standard deviation is 5, so the next value should be 5 away from the average. So if the average is 3 and my standard deviation is 5, the next value should be 8, 5 numbers away from the middle. And from 8, I've got another standard deviation, so I can do another plus 5 in this pattern to get 12, 13. And I could keep on going. But I could go in the negative direction as well, because I could be 5 away on either side, right? That really doesn't matter. But if I had a really low standard deviation, let's say, average of still 3, but maybe my standard deviation is 0.1. Well, now all my numbers are way closer together because one value is going to be 3, the other one will be 3.1, and then 3.2, and so on and so on and so on. So all of those data numbers are much closer together with a lower standard of deviation. Okay, so if you have a high standard of deviation, the data is more spread out, but a lower standard deviation means data is closer to the mean. Right? Everything is a lot closer together. Okay, so we've got an example here just to help illustrate this. So the average age in 2 different daycares is 4 years. Right? Kids, they just can't go to school yet because they're not 5. Right? So the standard deviation in daycare A is 1.26. I know the average there is 4, but the standard deviation in daycare B is 2.32. Again, the average is still 4. So use the standard deviations to compare the ages here. So if you think about daycare A, so let's label this as daycare A. Well, again, if I know what the average is, which is 4, and I know that the standard deviation is 1.26, well, I could come up with like a range of ages that could potentially be here. So if 4 is my number in the middle, well, I could do 4 plus 1.26 to get the next range of ages, so 5.26. Or I could go the other way and do 4 minus 1.26 to get an age on the lower side of this pattern, right? 2.74. So here is a situation for this daycare. Now you can't do this again because you have kids that are way too small to be at daycare yet, right? Under 2, their parents are still probably home on maternity leave taking care of them. So, and you wouldn't go bigger than 5.26 because they'd be already in grade 1 or 2. So really, this is the age range that makes sense here. So at daycare A, I have kids ranging from almost 3 to just over 5, which makes sense. If you think about the same thing in daycare B, we'll do this one more time. Again, the average is 4, and the standard deviation is a little bigger this time, 2.32. 4 is in the middle, so if I do this on the bigger side, 6 something, 6.32 is what that would be, 6.32. And then if I go back the other way, an age of 1.68. So if you think about daycare B, the age range is much further apart, right? You've got kids that are from anywhere just under 2 to just over 6. So since that standard deviation is bigger, you're going to see a wider dispersion in the age range of the children that are there. Here's your calculator steps to do this. So you've got all the buttons that you need there, all the menus, what it would look like. So you can do this one more time with this example. So we can throw all those numbers in there. Now the nice thing about this is your calculator has a bunch of different lists that you can use. So I think it goes up to 6. Oh, well, it goes up to 5. So you can put in any other ones you want, or you can just clear everything out from list 1, but it gets annoying having to delete all the values one by one. So if you press second plus to get into your memory screen, option number 4 will clear out all the lists. And then you just have to hit enter. Your calculator will say done, and they are all deleted. So now we can go back into stat edit. The list is cleared out, so you can put everything back into there. So we'll put in all our numbers. So 15, enter, and then 12, 13, 9, 2, 9, 17, 25, 13, and 11. Okay, so got them all in there. And then we can go again, stat edit, or stat calculate, I should say. Option number 1 is one variable stats. And again, I don't really need to tell my calculator it's list 1. You can if you want. I believe if you have the 83s, you might have to, but you shouldn't on the 84s. And by default, that's the only list that's in there. So you can type in those numbers again. So the mean, again, is that X bar. So 12.6. Median will tell you, if you scroll down far enough, is 12.5. And your standard deviation is at the top, 5.66, so nearest 10th, 5.7. Okay. So sometimes you'll be asked to do mean, median, standard deviation using what we call a frequency table, and it has 2 columns. So the next example we'll do has that. In order to do it, we have to use 2 columns in our calculator, one of them for the data, and the other one is the frequency. Right, how many times that data entry occurs. So it's a nice way of us saving some time. Rather than hitting the same number in 10 times, we can just say that this data point shows up 10 times, rather than doing 10 specific entries. So we won't do this example 5, this survey one, but what we will do is this last one at the bottom to illustrate this. So you've got a table here, number of shots per game by a hockey player during the course of one season. Find the mean, median, mode, range, standard deviation, all values to the nearest 10th. So you've got specific data points of the number of shots, anywhere from 0 to 6, right, in a game, and the number of games that specific value happens in. So there were 5 games this season where this player took no shots. There were 11 games where they had 1, 5 games where they had 2, so on and so on and so on. So these individually, there's not only 1, 2, 3, there's not only 7 data points, there's much more than that because we're counting the number of games as well. So this is what the frequency would be. So here's the frequency, how frequent these data points occurred. So rather than us hitting 0 5 times in our list, I can do 2 lists. One list has the data, the other the frequency, and then I can find all the things that I need to, rather than, you know, typing everything in one by one. So I'll go back into stat, edit. Actually, let's clear the list out first. So second memory, clear all lists, option 4, done. So stat edit, and my lists are cleared. So I'm going to put in list 1 the number of shots. So anywhere from 0 to 6. So 0, 1, 2, 3, 4, 5, and 6. And then the frequencies will go in list number 2. So if I hit my right arrow key, or my right cursor on the calculator, it'll take me over there. So 5, then 11, then 5 again, then 6, then 3, then 2, then 1. Here it's very important that your frequency matches up to its specific data point. If they're out of order, you're going to have, you know, different values than what you need. So if I were to accidentally switch the 11 and the 5 in the number of games, then it would say that this person took 1 shot in 5 games rather than 1 shot in 11 games. That makes a big difference. So make sure the order is correct, everything is where it's supposed to be, and then we will hit our stat calculate. But here I actually have to define both lists. The first list contains all the data, the second list contains the frequencies, and I believe I have to separate them with a comma. I don't really remember, but we'll see if it works and does what I want. If not, then I'll try it the other way. So define both lists, separated with a comma, hit enter, and it looks like it did exactly what I wanted to. This looks perfect. Okay, so I do have to separate them with a comma here. So in terms of finding all of those values, here's the mean. Again, remember it's x bar. At the very top, 2.0. That's to the nearest 10. So on average, this person takes 2 shots a game, is what this says. 2 shots per game. Okay, that is their average for the amount of shots they take. The median, the middle value, if I scroll down again, MED, median's 2. Right, so that's the one right in the middle. If I were to lay out all of the data sets, all the data entries, 2 would be my middle value. The mode. Okay, the most repeated value is, well, 1. Right? That's the most value, that's the most number of shots they take over the course of the season. That keeps repeating. So there were 11 games where they only had 1 shot. Okay, the most repeated one is the mode. Range. Well, if you think about all the data entries, the biggest data number is 6, the smallest is 0, so that range should be 6. Okay, and then the last one, standard deviation. How far away are these numbers from the average? So I can scroll back to the top. There's my sigma, 1.6. Okay, so there it is. In total, if you needed to think of how long this season happened to be, if you looked at how many games it was, well, there were 33 games in total. Right? So in my calculator, I would have had to enter 33 different rows if I did this the way we previously did back in the beginning of the video. But since there's 33 games, your calculator will say that there were 33 data entries here, which makes sense. There's 33 values because of the fact that the frequencies should add up to 33. Right? So those numbers need to match as well. So again, just another way to double check. Okay, so it's very, very calculator heavy here. So you'll see a nice big summary at the back, what we did. You'll find the solutions, everything all filled in, some practice problems underneath if you want them. And we'll see you in that second video here, linked just in the corner above, where we'll start to talk about that bell curve, that normal distribution. So we'll see you next time. Take care.